Okay, so today's short notes are going to be all about factoring higher degree polynomials. And so what we want to do is always look for a GCF first, because that can make life a lot easier when you're factoring. So when I look at this first polynomial, 2m to the fourth plus 6m cubed, I notice the coefficients have a common factor of 2, and the variables have a common factor of m cubed. So my GCF is going to be 2m cubed, and then we're going to basically divide that out of both of these. And that's going to leave me with m for the first thing, and then plus 3. And then if you're not sure if you've done it right, just take a second, imagine distributing these in. Would you get what you intended? Would you get the original expression? And that's it. All right, so let's take a look at that next one. I've got 3 terms this time. The coefficients don't have any common factors, but there is a common x among all of those. So I'm just going to take out the x, and then I'm going to be left with 3 terms inside. So we're basically dividing every one of these by x. So the power of x is dropping. So x squared minus 4x minus 21. Then it's our job. We'll just keep that GCF set aside, and now we have a trinomial that we're going to factor. We're looking for factors of 21, so 1 and 21, or 3 and 7, that would add up to 4. 3 and 7 look like a more likely pair. So I'm going to do x and x, 3 and 7. And when the binomials just have an x at the front of each of them, and neither of them have like a number in front, then it's very straightforward for the factoring. We just want these things to add up to negative 4. So that would be minus 7 and plus 3. And we can do the rainbow method to just check. So that would be negative 7x when we do our outer terms, positive 3x when we do our inner terms, and that would add up to our negative 4x. All right, so that rainbow there is just to check your own work and make sure that we actually get values that add up to the negative 4x. All right, this next one has a lot of things going on. I see that we have coefficients that have a greatest common factor of 3 and variables that have x squared in common. So whenever we're factoring, we've talked about this in the past, we really don't want something in front of our x squared when we go to factor a quadratic. So for our GCF, we're not just going to take out 3, we're going to take out negative 3. And then we're also going to take out x squared. And that's going to be from all of these. So we're going to basically divide out negative 3x squared from all of these. And that's going to leave me with x squared, and then positive x, and then negative 6. So now we're just going to factor that quadratic like we know how. We're looking for things that multiply to negative 6 and add up to 1. So I've got my x, and then my factors for 6. 1 and 6, 2 and 3. The ones that are 1 apart are going to be that 2 and 3. That's what we're going to use. So 2 and 3. And if I want them to add up to positive 1 for that b value, I'm going to be plus 3 and minus 2. Now don't forget that GCF that we factored out is still there. It doesn't disappear. We just set it aside, and then we factor our quadratic a little more easily. Okay, for number 4, only 2 terms this time. We have a GCF again. Our coefficients have a GCF of 3, and then our variables have x in common. So I'm going to divide 3x out of both of those terms, and that's going to leave me with x squared minus 4. All right, so we've been doing this for a little bit. This should kind of stand out to you. X squared minus 4 is a difference of squares, and they always factor the same way. They're going to look nearly identical. So we're going to have 2 binomials, and they have to start with identical factors that multiply to make our first term, and then identical values that multiply to make our second term go in the second part of our binomial. They just have to be opposite signs, so that way when I do my outer terms and my inner terms, they essentially cancel out. All right, so we got our GCF out, and then we had a difference of squares that we factored, and those are our 3 factors for this polynomial. All right, next up, look at our coefficients. They're all divisible by 3. and then the highest power of x that we can take out of anything is going to be x cubed. And so we're going to divide that out of everything. So divided by the first one, I get x squared. On the second one, 6x. On the last one, plus 9. Okay, so now we're going to factor that quadratic. And we're looking for things that multiply to 9 and add to 6. And when we're talking about 9, we have 1 and 9 or 3 and 3. 3 and 3 is what we're looking at. Plus 3 and plus 3. Multiply to positive 9 and add up to positive 6. All right, so taking those GCFs out makes it so much easier to factor, but not every polynomial is going to have a GCF. So if I look at number 6, I've got x to the 4th minus 13x squared plus 36. So we don't have a GCF to work with, but we do have all even powers. And so I can factor this sort of like we would factor a quadratic. The only difference is I'm not going to start each binomial with just x. I'm going to start them with x squared. That way when I multiply them, I get x to the 4th. And then when I do my outer terms, I have some number of x squareds, and my inner terms, some number of x squareds. And we need that to add up to negative 13. And then our last numbers need to multiply to 36. So when I look at factors of 36, the ones that jump out to me right away are not the ones I'm writing right now, but 4 and 9. Because if I had a 4 here and a 9 here, this would be 4x squared, this would be 9x squared. In order for them to multiply to a positive and add to a negative, they both have to be negative. Okay, so that's just us checking. Now if you notice, x squared minus 4 and x squared minus 9 are just like what we talked about over here on number 4. It's a difference of squares. So I'm going to factor each of these into its two binomials, x minus 2, x plus 2. And then for x squared minus 9, x minus 3, x plus 3. So we have fully factored it. If you stop at the line above, just x squared minus 4 and x squared minus 9, you haven't finished. You're not completely factored. Okay, so one other thing we're going to look at is something called factoring by grouping. We're going to use this for polynomials that have 4 terms. When they've got 4 terms like this, we're not going to have a GCF. What we're going to have to do is kind of look for pairs within this polynomial that have a GCF. So what I see right away is I see this 3x squared and this minus 3, and then I see this x cubed and negative x. And each of those have something in common if we just kind of separate them. So I'm going to take x cubed minus x here, and then plus 3x squared minus 3. Now what I'm going to do from the first pair is take out the GCF from just those two. So those have x in common, and then x squared minus 1. When I look at the next pair, the 3x squared minus 3, the GCF for those two is 3. And then I have x squared minus 1. So if you notice, when we did that factoring, where we only took pairs of them, these factors right here match. So x squared minus 1 is one of our factors. We're going to bring that down. And then our next factor is going to come from the factors that we took out of each of those. So that's going to be x plus 3. So that's factoring by grouping. We want to take out a GCF from two pairs separately, and we can do this only when these factors match. So that x squared minus 1 and x squared minus 1, they had to be the same for this to work. So we've got this factored out, and then actually, if you notice, we've got x squared minus 1, which can be factored further. X plus 3 stays like it is, and then difference of squares, x minus 1, x plus 1. And now we're fully factored. So when you look at number 2 here, it looks like we could group these a couple different ways. And if we just try it by grouping these two together, my GCF would be x squared, and then I have x minus 2. And then if I take these two, negative 16x plus 32, my GCF is going to be negative 16, and that's going to leave me with x minus 2. All right, so my factors match again, just like last time. X minus 2 and x minus 2 match. So that's going to be one of my factors, x minus 2. And then my other factor is going to be the GCF that we took out of each of those prior. So that x squared comes here, and the minus 16 comes here. And then again, like last time, x squared minus 16 is a difference of squares. So let's factor that all the way. X minus 4, x plus 4, and then x minus 2. All right, fully factored. All right, these last two, we're going to look at these, and it's pretty easy to identify what you want to put together. We can only group this one way. I can only group the 4x cubed and the 12x together. Those are divisible by 4, and then these are going to be divisible by 25. So for the first pair, I'm going to do 4x squared as my GCF, and that's going to leave me with x minus 3. And then on the next one, I'm going to take that negative 25 out, and that's going to be x minus 3 also. All right, so we got those x minus 3s. X minus 3 is one of my factors now. And then I need to take the coefficients here and here, or the GCFs rather. 4x squared minus 25. 4x squared minus 25 is also a difference of squares. So this one's just a little more complicated because of the 4 in front of the x squared. But remember, these have to match. So the only way that works is 2x and 2x. 5 and 5. One gets a plus, one gets a minus. And then bring down that x minus 3 that we had already factored out. Okay, last one. We're going to take those first two terms again. 6 and 15 have a GCF. 8 and 20 have a GCF. So that's how I know how to group these. So I'm going to take 6x squared. Nope, just kidding. I'm going to take 3x squared out of both of those. And that's going to leave me with 2x plus 5. And then for the next ones, I'm going to take out positive 4, and that's going to leave me with 2x plus 5. So 2x plus 5 is one of my factors. And then the other one, I just take those GCFs, put them in together as one factor, 3x squared plus 4. Now that's not a difference of squares, so there's no more factoring beyond this point. We are done. So that's factoring by grouping. You just want to look for the GCF for a pair of numbers and work from there.